Hi, Mr. Fabico. It's me.
And me.
And today we're gonna record a really fun and a really entertaining 10-minute video about our app.
Today we'll be analyzing a speedometer app.
Thank God, not a measuring app, right?
How do I access it though?
Let me show you. In order to access this amazing, super duper incredible app, you have to go to App Store or Google Play Store and type speedometer in the search bar. Later, you download the Speedometer simple app and click the amazing button open. You're right there. Congratulations.
When you make it to the app, you'll see three things: a speedometer, a compass, and your location. When you swipe left, you'll see the time you open the app, your duration of use, average speed, and top speed. If you swipe one more time, you'll find your elevation and distance from your starting point in meters. In the app settings, you can change your units of speed and units of elevation. You also have the option to turn on speak speed, which means the speed is spoken when the screen is tapped. At first we were going to do this, but then we found out that it was super delayed and we ended up not using it. In our experiment, we used the Speedometer simple app to calculate my car's acceleration. We measured a delta x and took v-final measurements from the app. We then used kinematics to arrive at the final value of acceleration.
Okie dokie, guys. First, we have to measure distance. We need like 10 meters, but we're not super duper cool at measuring, so we'll do uncertainty plus or minus 0.5 meters. Okay, so we pinpointed 2 spots, and now we know where those 10 meters start and end. Alex backed out his car, and in order to be as accurate as possible, I walked out of the car and navigated the front of the car using hand signals to be at the very starting point. Do you remember how Alex kicked me out of the car? Well, I'm back in recording app speedometer. And this is Alex driving dangerously and recording car speedometer at the same time. In total, we did 3 trials recording cars and app speedometers both at the same time. Top speed is what we need, and it's measured in kilometers per hour. What is she doing? She's trying to learn physics. Oh my god, it's calculations part. So fun. Okay, basically in this experiment, one of the most important parts, in my opinion, was to convert all the units to meters per second, SI units, because our car was measuring everything in miles per hour because we live in the US. And our app was measuring everything in kilometers per hour, so we decided to convert everything to meters per second because that's the universal and the easiest unit to use for everything. And our delta x, which was the distance the car traveled, was also in meters, so it was 10 plus or minus 0.5 meters, as we already established. We did 3 different trials for the app speedometer to find the velocity and for the car speedometer, and the initial velocity for all 3 trials was 0 meters per second. We found data, and using kinematics equation number 4, which is the equation is final velocity squared equals initial velocity squared, which in this case is 0 plus 2a delta x. From there, we calculated acceleration for every single trial for both app and the car, and then we averaged the accelerations and we got our results. So the acceleration for the measured by the app was 0.836 plus or minus 0.044 meters per second squared, and our results for the car was acceleration is approximately 0.936 plus or minus 0.050 meters per second squared. Yes, very interesting, isn't it?
GPS stands for Global Positioning System. We've all heard about it. It's in our phones, our laptops, iPads, smartwatches, but have you ever wondered how it actually works? Before I did research, I had the notion that GPS was just a single satellite communicating with my phone. But in reality, there's so much more to it. Our app, Speedometer Simple, uses GPS to calculate velocity. But how does GPS actually work? And what does it mean to send and receive a signal? What are its pitfalls? Why is GPS sometimes unreliable? And how could this affect the app's calculation of velocity? To understand how satellites work in 3D space, we must first understand how they work on a 2D plane. To locate a point on the 2D plane, we use a method called trilateration. The first satellite indicates an entire circle where the point could be. The second creates two possible points, and the third verifies one of those 2 points, locating its final position. Now, GPS systems still use trilateration, but with the addition of one more satellite. It would only make sense that if we add one more dimension, you need one more satellite to locate a point's position. And because 3D space has spheres, not circles, that is represented in this first intersection. Here, the two spheres create a ring around which the point can be located. Next, a third sphere intersects the ring at 2 points, and lastly, the fourth sphere verifies one of those locations. Now you know that GPS systems need at least 4 satellites to calculate your position on Earth. And now you can tell everybody you know how GPS works. In spite of its ingenuity, GPS still has its pitfalls, which can decrease the accuracy of position readings and consequently hinder the accuracy of the app velocity values. One of these pitfalls is called multipath error, or GPS bounce. It's exactly what the name suggests. The GPS signal, instead of following an undisturbed path from satellite to receiver, can be deflected off buildings and other surrounding surfaces. This means that the signal takes longer to reach the satellite and results in inaccurate distance readings. Satellite geometry is also a very important factor when it comes to GPS precision. Satellites require an ample amount of space between them to reduce interference. If there isn't enough space, signals can get disturbed and cause false data. Satellites need enough space in between them so they can give accurate readings. Signals can also be altered due to atmospheric conditions. In the atmosphere, there is a section called the ionosphere. And yes, sphere is spelled wrong. The ionosphere is abundant with charged particles, which can interfere with satellites' radio signals. The more distant signals travel in the ionosphere, the more likely they are to be disrupted. That's why satellites directly above the receiver will more often give an accurate distance measurement than a satellite closer to the horizon. Now, it may seem obvious, but not having enough satellites overhead can decrease accuracy. Although you only technically need 4 satellites for a reading, 7 or more gives you a better and more precise one. If you have 3 or less satellites above you, your GPS signal will be lost. Has your mom ever told you, "It's that damn phone of yours"? Well, this time it actually is. Poor hardware can cause GPS signal to be lost or inaccurate. This is just the tip of the iceberg when it comes to GPS. But in reality, GPS is very accurate, usually within 6 to 10 meters of your true position. This accuracy can be seen in our calculations, which showed that the app's velocity reading was very similar to that of the car's.
Pros and cons, let's go! Okay, let's start with pros. Number 1, it's accurate enough. We compared apps and car speedometers and they have an overlap, so I would consider it as a pro. Number 2, it has a bunch of different features. For example, it can tell you where you're at. It literally has a map. It can tell you your level of elevation, and also it has a compass in it. Pro number 3, it has different units, so if you want to measure your velocity in meters per second, you can do that. Miles per hour, kilometers per hour, it's all available. You just have to change the settings. Pro number 4, you can record your trips. So if you're not able to look at it right away, you can click at the button record and then go back to your trip history and watch your velocities over time, which actually another pro because it also tells you your average velocity. It has not only top velocity but also average velocity. And there's one more reason number 6, pro. You can tap at the screen and it will tell you your velocity at this very second. cons. Okay, well, con number 1 is that tap to speech is actually delayed. Boo! Yeah, so the one that we were talking about in prawns is actually delayed. So you will tap on the screen and it will tell you what your velocity was like 2 seconds ago. But if you want to know right now, you have to look. So that's a con. Number 2, no graphs of data. You can't analyze anything in this app. Unless you're doing it by yourself, you can only collect data in this app. And con number 3, not immediately responsive. Like, for example, car speedometer will tell us what the car speed is at this very second right now, but using this app, it will take a little bit longer. It doesn't tell you right away exactly what your velocity is. It's a little bit delayed. So yeah, that's pretty much it. Bye-bye.
We rate this app
this
4 salsas
out of 5 sour
Oh
cream.
my god.